Hello everyone, welcome to class today. Today I want to talk about function. And you may have heard this term a lot in real life, like how's this thing function, but this is mathematical function. It's a little bit different than that. So to actually understand it, and if you go on in mathematics, you will actually see use a lot of function in the future. But right now, let's try to understand what actually is a function in mathematics. To get to that, let's have a little bit of motivation. All right. So function was beginning, people thought of it to represent a relationship or something depends on another thing. For example, if you go to the post office and you want to mail your stuff, your package, what are they going to do? They're going to weight your package, right? And then depending on how much your package weighs, you're going to have a different price. Let me write here, for example, between weight and cost, right? For example, I'm just making up these numbers. Uh, let's say if you have a weight of 5 grams, you are going to have to pay 50 cents for your package. If you have a package of 10 grams, you are going to have to pay, let's say, 100 cents, which is a dollar, which is just, I'm writing it in cents for a couple later. What about packets of 15 grams? Maybe you're gonna need to pay 150 cents. All right? So that's a relationship. You have a relationship between the weight of your package and the price that you have to pay, the cost. All right? That's a good motivation, right? How about another example? Example number 2. Let's say you want to tell your friend that today it's hotter than tomorrow, or you want to tell your friend, hey, you know what, today is actually it's colder than yesterday, right? So you're going to have a temperature to measure how hot or how cold it is versus the date. You want to have tomorrow and today and yesterday. So you may want to have on one thing, you have the date. And you want to talk about how hot or how cold it is. So you need a temperature. Right? Let me just, I don't know, give it a fake example. And we have today, let's just say today is the 5th. The 5th, and then the temperature is, I don't know, I'm just making this up again, 30 degrees Celsius, not Fahrenheit, okay? Let's see. Okay. What about tomorrow? The 6th. Maybe I say getting hotter, right? So, 32. I don't know. Yes. And the day after tomorrow, maybe you get going down. Let's get 38. Let's get colder, get cooler. All right. All right. So these are the type of thing that we want to understand, so that we invented functions. Right. You have a relationship dependence. So the weight, the cost of a package is depending on its weight. The temperature maybe depend on the date. So we have that kind of thing. So in a term, a function is just going to tell you this relationship, this dependencies, a rule that will tell you, okay, how much weight and how much cost is it. It's going to assign something in here in weight and give you something in here, a cost. Okay? So if you like or going to go into computer science, you're going to have something on the left. You're going to put in the weight and then going to tell you how much does it cost, right? So here you have input. And throughout this, which we're going to name it function. We're going to have an output. Right? For example, if I am talking about this example number 1, I'm going to input my input. It's 5-gram package. 5-gram package. The output, I'm going to have to pay 50 cents. Right? Now, everyone can see, or I can try this. If it's 10 gram as my input, what's my output? Right, 100 cents. Right? So this is a machinery way of thinking about it. Okay. Now you notice that I put it in look like a table here. So there's things on the left and things on the right. Then there's this dependency. This is also another way that you can try to describe a function. Right, representation of a function is in a table form. You can have the input on the left, and then the output on the right. That's a good way of. That's also a good way of representing a function, right? Now, if I just decided to, every time I need a table or every time I need to write it in picture like this, maybe I'm gonna use up all my chalk. So people tend to think of a shorter way of trying to describe a function, okay? So first of all, you know, in order to describe anything, at least we need to know what its name is. Like if I want to know you, Kevin, I should. All right, I just said your name is Kevin, so if I have a picture of Kevin in my mind, right, I need a name first. So, what do you need? So, roughly speaking, which is, we're going to get to the definition in a moment, but continue. No, sorry, nope. No. So, what does a function need? So, function needs name. Right, people tend to give it a name like, I don't know, history have given these names F, G, H. I'm giving you a K too for Kevin or Hoy, yes. Anyway, you need to have a name. And then what next? I need to tell you what does it do. And what is the other word of telling something that it's do is the role. What does the function do? Right, I need to tell you that. Also, you notice there is name for input and there is name for output. So input name or in mathematical terms called a variable, because it varies, it changes. You see, we have 5 gram, 10 gram, 15 gram, may have 20 gram, that's it changing, right? So that's why you have the word variable, all right? Well, you're gonna need a name for it. We could have a bunch of names for it, but usually people like X, A, you know, could have B, anything, all right? And then how am I going to represent once I have the input, I should have the output. And the way to represent the output, once you have the output, and if you choose your function name, like let's say I choose my function name of f, and I choose my input as x, I'm going to write my output nicely, f, parenthesis, x in there. What's in the parenthesis, double parentheses here, is whatever you consider to be the input and the name of the function f. Of course, we're going to look back at the role and see what does it do, what does the function do, right? For now, I'm going to continue by erasing my second thing. I'm going to use that first example in a moment. That's why I'm going to erase that. need to use my first example and keep it up there. All right, everyone okay with I'm erasing this, right? All right. Let me have this thing here. All right. Well, that's what a function needs, right? We haven't get to the exact definition yet, but that's what a function needs. Let's see. Let me give you an example. For example, my function f. Yes, the name f. Hey, wait a minute. Let's change it to something else now, right? I don't need to use f all the time. Like I said, there's a bunch of names for the function, right? F, G, H, K, whatever you want. So let's call my function g. And the rule I'm going to do to it is take a number, take the number, add 3 to it. Alright? Okay, so rule. Take the number, add 3 to it. Add 3 to it. And I'm gonna choose my my input. Give it a name. I'm gonna give it a name like input name. I'm gonna choose it as A. I'm gonna choose it A. All right. So how am I gonna write this in a shorter way? Well, my function name is g, right? G. And we're gonna have the parentheses, and I choose the input as A. All right. And I'll close, and they do equal. So what do I do with this number with my input? Well, take the number, okay, A, add 3. Oh, let's know how to write add 3. So that's my function. In fact, later on, if you study more in mathematics in the future, people just prefer to write this way for a function because it's short, right? Okay. So, what is actually is a function? Let's get to what we want today. Definition. A function is a rule that assign an element. I'm going to give it a name now, just like I did here, given the input name. An element x in a set A. Alright, like this one. This is the set of all the weights of the package that you want to give the mailer. 2. Notice the term, this is important here. Exactly 1. Okay? Element in element, okay, let's give it a name too. Sorry, I should name my function. I should name my function as f. Okay? So what is to an element? The name of it got to be f of x. The thing's in the output, right? F, x, so g, a over here. And what's that? B. Okay. So what is it so important about the thing that I have here? Exactly 1. What is it? What is it so important? Well, coming back to this example, you are going to get prices for your package. You know, if I say to Kevin here, you have a package of 5 grams, I'm going to charge you 50 cents. And then Cindy here also have a package of 5 grams. I should charge her the same thing. I should charge her 50 cents. I shouldn't be different, right? So they both, because they both have the input as 5 grams. That's the natural thing of understanding it. I shouldn't have a different price for different prices, different output for the same input, right? So I cannot have a 5 gram package, but here I'm going to charge 50 cents because I like Kevin, and I'm going to charge Cindy 60 cents because I don't like Cindy. I'm going to charge her higher. No, I'm not going to do that. Okay. Well, it's mathematically I'm not going to do it, but who knows? All right. So that's the importance of having exactly one element in fx. Okay. Now, if somebody give you this type of thing, this is called formula. You know, you have g of a equal a plus 3. Can you evaluate? Can you get to know that? Well, what are you going to do? Let's say I want to evaluate g of 5. What I want to do is take 5 of my a as input. What am I going to do? I'm add 3 to that number, right? 5 here plus 3. I get myself an 8. That's the value. So you can actually go on and evaluate it. But to recap, and the most important thing today that we learn in this section is what a function is, the definition of a function. And the most important thing is you only have one output for each input that you have. You cannot have, I repeat again, you cannot have 2 outputs for 1 input. That's the most important thing that I want you to leave the room and remember. Well, thank you for coming today and have a good time. Bye-bye.